Hello everyone, welcome back to my YouTube channel Unfog with Dr. Atahar Parveen. So this lecture is going to be the part 3 lecture of the electromagnetic radiation chapter. Before starting to discuss the class, I want to request you all to subscribe to this channel because we will be posting regular classes from now on for teacher recruitment exams like HSTR and GPSTR, because we all know that the education minister has already announced about 10,000 posts for teacher recruitment in the coming academic years. So please be serious and start preparing, and your likes and shares matter to us. That is the motivation for us to make the next class. Okay, so few aspirants were requesting me to post the class soon, but the thing is, if there are very few views in my videos, then I don't get motivated to upload the next video. So that is the matter here, and that is a human tendency also, right? So I feel that maybe the class is not useful for you, so it will get delayed. So if you want regular classes, then keep liking the videos and also writing your feedback in the comment section. Okay, so now let us start the class for electromagnetic radiation. In the first class of this chapter, we discussed about meaning, examples, properties, and the uses of different electromagnetic radiations. And the second class we dedicated for photoelectric effect, which you all have not watched. So please first watch the class 1 and the second class based on the photoelectric effect, then only come for this lecture, because things will become discontinued for you all and you may not understand few concepts here. Okay, and in this present class we will discuss all about experimental facts about photoelectric effect, Einstein's explanation and applications of photoelectric effect, and of course we will discuss about electromagnetic spectrum also. And at the end of the class we will discuss the most expected multiple choice questions from this part of the chapter. Okay, so please try to watch the full lecture, because then only you will get full information. If you skip and watch, no, you will miss many important points, because each and every line which I will be talking can be made as a multiple choice question and can be asked in your exam. Okay, so let us start the class. So we stopped our previous class here. So we told you that we wanted to talk about photons more, and want to get into deeper knowledge related to photons, because the photons are the main heroes of this chapter. So let us start with more information related to photon. We know about this wave, right? Now let's see these two types of waves. This is one wave, this is another wave. In the first wave, you can see that the wavelength is short. In the second wave, the wavelength is long. Why? Because in the first wave, frequency is high and frequency is inversely proportional to wavelength. That's why high frequency means that wave will have short wavelength. And in the second case, the wavelength is large. The long wavelength is there. That means the frequency will be low. For the same reason, frequency is inversely proportional to wavelength. Now if I see the amplitude, here the amplitude A is there, no? This is changing or not? Yes, this is changing. If you have high frequency, then the amplitude will be high. If you have low frequency, then your amplitude will be low. Why? Because we told that nu is equal to C upon lambda. Remember, nu is equal to C upon lambda, and your energy is also related to the frequency. Energy is equal to H into nu. That means your high frequency implies that that wave is having high energy. Your low frequency means that wave is having low energy. Okay. Now, we also know about a certain parameter known as intensity. What is intensity? Intensity means number of photons. If intensity is increasing means you are telling that the photons number is increasing. Increasing number of photons means increase in intensity. See, for example, if this is a metal block, now I am giving only one light ray, I am putting incident on that metal, then I am getting one electron ejected. If I want to increase the intensity of the light ray, what I will do? I will give more light rays, right? So now I am increasing the light waves. This increase in light waves is nothing but increase in intensity, which in turn is increasing the number of electrons ejected. That means more photoelectrons are ejected with a more intensity. Now let me give one simple summary. See, when I talk about intensity, that is if the number of photons are increasing, what all will happen? If intensity is increasing means number of photons are increasing. Intensity is increasing means number of emitted electrons are also increasing, and intensity is increasing means photoelectric current is also increasing. Isn't it? Increase in intensity means number of photons are increasing. Increasing intensity means number of emitted electrons are increasing. And this number of emitted electrons will constitute a current which we call photoelectric current. Because they are increasing, current will also increase. So intensity plays a major role here. Now I ask you one question. Does the kinetic energy change? No, it will not change. This you should not get confused here. If intensity is increasing, kinetic energy of electrons will not change. Here I will give you one simple example. This, I think men will relate to this example. When in your childhood you used to play that game, right? Especially in Karnataka we play it. That marbles on the road you play with your friends, right? In your childhood you must have played. You gather many marbles on the road, you make one circle and you put marbles. Then you beat one, each one of you will beat one marble in that group. Isn't it? What will happen? You beat one marble, marble will come out. Isn't it? Now you imagine this photon as that marble. And those group of marbles are there. Now imagine them as electrons on the surface of the metal. Now I can give you nice explanation on this. See, if you are beating one marble means maybe one or two marbles may come out because they are together. But if you beat with many marbles at a time, many marbles will come out, isn't it? That means you are changing the intensity, you are increasing the intensity of the marbles. Therefore, those marbles which are coming out, they are becoming many. Many marbles are coming out. But are you changing the speed of the marbles which are coming out? No. Kinetic energy is related to the speed, right? If you want to change the speed of the marbles coming out, then you don't need to use many marbles to beat them. You can use only one marble and you can beat it very fastly. That means you can change the frequency of that marble. You can increase the frequency of that marble. If you beat that very fastly, then one electron or one marble from that rod, it will come out very fastly. Then you are changing the kinetic energy. Okay. So you are not changing the kinetic energy by the intensity of the photon here. You will change the kinetic energy by the change in frequency of the photon here. Okay. If you all have understood, well and good. I will talk on this more. If you have not understood, you will understand it. Don't worry. Please watch the full lecture patiently. Now what this Hertz did is, he conducted one experiment. In that experiment, this was to study the photoelectric effect. This is an experiment for photoelectric effect. One glass evacuated tube was taken. In that one window was made. That window was from cords. It was made from cords. Then two plates were attached. One plate was C and the other plate was A. The cathode and the anode. Now this plate C, it is a emitter plate. It is a photosensitive plate. Why it is becoming emitter means your light, it is getting incident on this plate. Once the light falls on this metal plate, what will happen? Electrons will get ejected, right? These electrons are being collected at A. That's why this A becomes the collector plate. Okay, C is the emitter plate and A is the collector plate. Now you can see that before I incident this light on this photosensitive plate or the emitter plate, before that the circuit will be incomplete, right? Where is the connection? You can see that this C is attached to a rheostat, the commutator, the microampere ammeter, then voltmeter and a battery. A is also attached here to the rheostat, isn't it? But are C and A connected to each other with any wire? No, there is no circuit, right? But when the light falls on this photosensitive plate, the emitter plate, electrons are emitted and then they are getting collected at the collector plate A, which forms the flow in current. So your circuit becomes complete here. These electrons which are moving from C to A, they form a virtual wire, isn't it? That's the reason why your circuit gets completed here. So this current is known as photocurrent. You can measure this current with the ammeter because this will be a very less current. That's why we are connecting a microammeter. It will not be a milliampere. It will be a microampere ammeter. This will be very less current. So all the play in this photoelectric effect is about that photocurrent. Okay. Now people also have graphs and all that are not very important, but I'll give you a glance on all that. Now with this experiment, there were few observations, the conclusions of the experiment. What were they? First is that photoelectric effect depends on intensity of photons. We can plot the graph also. You can see that the photoelectric current is linearly proportional to the intensity of light. Here I have put this diagram here to make you all understand it easily. See here in the first case, if I am incidenting with one torch, if I am incidenting a light ray or photons, then 3 of the electrons are coming out. If I will use 2, then 6 may come out. But am I changing the kinetic energy of these electrons? No, I am not changing the kinetic energy of electrons. I am just changing the number of photoelectrons which are getting ejected. So this is how intensity is related. Okay, and this energy is independent of intensity. Which energy? The kinetic energy. It is independent of intensity because intensity is just increasing the number of photoelectrons. It is not increasing the energy. Now, as I told you, this effect of potential on photoelectric current, it will be a straight line actually because you are connecting a battery, right? And this maximum kinetic energy of the electrons which are getting ejected should be equal to E into V naught. E is the electron charge, 1.6 into 10 raised to minus 19 coulomb. But this V naught is the stopping potential. If you plot this photocurrent, no, with collector plate and retarding potential, means that is the negative potential, you can find this stopping potential. But I am not talking on it because no, this is not important. So much deeper they will not go for HSTR and CRIS. They will ask all the general questions. They will not go so much deeper. Okay. These are all high level questions. So don't get into trouble by going so much deeper. Just if you know the gist, if you know the general part of the photoelectric effect, that is more than important for you all. So first observation was that photoelectric effect depends on intensity. Yes, it depends on intensity, but energy is independent of intensity. But then what will change the energy? It should be frequency, right? It should be frequency. Remember the example of the marbles. The frequency will change the energy. This was the second observation. See, if you have low frequency light, then no electrons were ejected. See, if you have low frequency light, no photoelectrons were ejected. So this is related to your threshold frequency nu naught. Nu naught means that frequency or the threshold frequency wherein greater than this nu naught only photoelectrons will be ejected. If the frequency of the light incident on the metal is less than this threshold frequency, then the photoelectrons will not be ejected. So if you have high frequency, then photoelectrons will be ejected with higher kinetic energy. Okay, here kinetic energy of photoelectrons, it will increase linearly with increase in frequency. This wavelength, the threshold wavelength lambda naught comes into picture here. This lambda naught is equals to C upon nu naught. We know that lambda is equals to C upon nu, right? It is inversely proportional. So that threshold frequency and threshold wavelength comes into picture here. Now when I say that the high frequency light ejects electron means change in frequency means change in wavelength. Change in wavelength means change in color of the light, isn't it? Remember the spectrum, the visible light spectrum. We have waveguides, right? You can see that the wavelength increases from the violet to the red. Low the wavelength, high the frequency. High the wavelength, low the frequency. So if you have high wavelength, that means low frequency, no photoelectrons will be ejected. If you have low wavelength of the light incident on that metal, then you have high frequency and photoelectrons will be ejected with more kinetic energy. See, for example, here I have metal block and I am putting red light on it. Red light is having high wavelength, low frequency, no photoelectrons, isn't it? Now if I incident a little bit lower wavelength light, that is green maybe, I will have photoelectrons because green is having higher frequency. Now the most highest frequency light, that is the blue color, then I will have electrons which are having more kinetic energy. Okay, these were the observations of photoelectric effect. The two main observations, that intensity is dependent on the number of photoelectrons ejected and frequency of the incident light is dependent on the kinetic energy of the photoelectrons ejected. Now this photoelectric effect, because of the photoelectric current, I told you, right, that photoelectric current will give many applications of photoelectric effect. One of the best is this photocell. Same process happens here also. You give the light and then electrons, they get collected at the collector region. They are emitted from the emitter plate and they are collected in the collector plate. And then photoelectric current will flow and then you can have a current in the photocell. Now this photocell, it has many practical applications. Along with this, there are many other practical applications of photoelectric effect. For example, it is used in electronic ignition circuits. Then it is used in measuring intensity of light in research, in laboratory. Many people use it there. And then it is used in automatic door opener. You must have seen in this big malls nowadays, no? Malls or supermarkets. You don't need to touch the gate. You just enter the gate, it will open by itself. There is some sensor, right? Here that photoelectric effect application is used. What happens? No, photoelectric current is flowing. When you go in between, no, when you go near that photoelectric current, it will get disturbed. When that photoelectric current is disturbed, what will happen? There is one sensor which will trigger that motor and then the door will open by itself. Once you go inside, again, if no one is coming in the way, again the door will close by itself. So this is the application of photoelectric effect. They can use in this auditorium, they can count people. How many disturbances are created in the photoelectric current? So many people are there in the auditorium. It is like that. And even traffic police also, they catch this traffic defaulters. At that time when their signal is on, right, the red signal is there, if still people are going, means they can count the number of people. They can see who is disturbing the photoelectric current and then they can catch them. And very important application is the burglar and fire alarms. They have these sensors. If that photoelectric current is getting disturbed by something, then that sensor will trigger and that alarms will ring. Okay, so these are all the applications of photoelectric effect. Now finally, by the observations of this photoelectric effect experiment, we can have the laws of photoelectric emission. The first law is that emission of electrons is possible only when sufficient amount of energy is incident. What is that sufficient amount of energy? That is work function phi naught. Then more light will eject more electrons with same kinetic energy. That means energy is independent of intensity. Remember the marbles example? That you can imagine if you are not understanding what I am trying to tell. Next law is that low frequency means no ejection of electrons. Only high frequency electrons will eject electrons with more kinetic energy. So frequency of the incident light is changing the kinetic energy of the photoelectrons. And last one, the instantaneous process is happening here in photoelectric effect. The photoelectric emission is instantaneous. See, just remember again the marble example. When you beat the marble to the group of marbles, does the marble take time? It will not take time, right? It will just, as soon as it will hit, it will come out. That only happens here also, because we are treating photons as particles, right? When one particle is beating the other particle, it will suddenly come out. It will not take any time. There is no time lag. If there is time lag also, it will be so less that it will be negligible. It will be around 10 raised to minus seconds, means 0.009 times 0.1. So much small time is there. That's why we can directly say that it's an instantaneous process without any time lag. After the observations and all the conclusions, Einstein explained why this is happening and how this is happening. He gave one equation, photoelectric equation. It is very well known equation. Let's talk on it. When a photon of energy h nu falls on the metal surface, energy is h nu, right? So when this photon falls on the metal surface, this energy of the photon is absorbed by the electron on the metal surface, and then after absorption, this energy it is used in two ways. The electron uses this energy in two ways. What is the first use? One part of energy it is used to overcome the surface barrier. It will use to come out of the metal surface. Okay, this energy we call as work function. This is also E is equals to h nu only. But we are giving that symbol phi naught, right? So here for frequency nu we will write nu naught. E is equals to h nu naught. Then the remaining part, which is remaining no energy, that is used in giving velocity to that emitted photoelectron. That's the reason why we are telling that if more energy we want from the photoelectron, then we have to give more energy. The photon. If more energy for the photon means energy is directly related to frequency, right? That's why E is equals to h nu. If the more frequency light is given, more kinetic energy will be there for the photoelectron. Okay. Now this is all was told by Einstein. Here you can see the depiction. One h nu we give, then we have this photoelectron with kinetic energy half mv square. According to law of conservation of energy, Einstein then gave this equation of photoelectric effect. He told that E is equal to whatever energy is there for the photoelectron, that is equal to these two energies. First is the work function plus the kinetic energy. Work function is h nu naught, right? Then the kinetic energy half mv square. And E is h nu, which is in the left hand side. With this we can say that the kinetic energy of the photoelectron is equal to h into nu minus nu naught. Okay, this is an important formula. You have to remember it. Now one question came in your HSTR question paper of 2015. The question was that which one of the following is the Einstein's photoelectric equation? E is equals to h nu naught plus half mv square. Now you can relate to it, right? Now let us discuss few most important multiple choice questions. So this is the first question. Which photon is more energetic, a red one or a violet one? And the options are both, red, violet, neither. Both means both red and violet, they have more energy. Neither means both red and violet does not have more energy. So here we need to understand the concept that the wavelength increases in VIBGYOR from violet to red color. Wavelength increases means frequency decreases. It means that violet color is having more frequency, which means that energy is more for violet. Okay, so this way you have to relate. Okay, higher the frequency, more is the energy. Okay, lower the wavelength, more is the frequency. Because the wavelength is lower, frequency is more, that's why energy is also more. So our answer will be option 3. Okay, violet. That is the correct answer for this question. Next important question. If the wavelength of electromagnetic radiation is doubled, what will happen to the energy of photons? The options they have given are remains the same, doubled, halved, infinite. See, try to understand the question. We have the formula E is equals to h nu, right? And also E is equals to hc upon lambda, right? So lambda is in denominator, because of which if the wavelength lambda will be doubled, energy will become half of hc. Okay, half of the numerator. It means that the energy should be halved here, because energy is inversely proportional to wavelength. You get my point, right? So if the wavelength of the electromagnetic radiation was made 4 times, then the energy would become 1 by 4 of whatever the numerator is. You get my point, right? Next important question. Which radiations will be most effective for the emission of electrons from a metallic surface? So this also you should understand that the answer should be ultraviolet rays, because the ultraviolet rays are having very high frequency. So more the frequency of the incident radiation, more will be its effect for the emission of electrons. Okay, more frequency is incident means more number of electrons will be ejected from that metallic surface. So that's why ultraviolet radiation will be the correct answer for this question. Okay. Next question. Give the unit of work function. So unit of work function is obviously electron volt. If you have watched our previous classes and this present class fully, you will get that the unit of work function is electron volt, which is a very easy question, but it is a very important question also. Next question. What is the time lag between the incidence of photons and the ejection of photoelectrons? We told that the time lag between the incidence of photons and the ejection of photoelectrons is instantaneous. It is so much quicker that the time lag is just less than 10 to the power minus 9 seconds. Okay, this is also a very important question. Next question. Which device works on the principle of photoelectric effect? See here, emission cell, junction diode, voltaic cell, all these have photo in their name, right? So all these devices work upon the principle of photoelectric effect. Okay, so all are correct here. Next question. The photoelectric effect was explained by, of course it was explained by Einstein. Photoelectric effect and Einstein, they go together. These two names go together and they are very, very famously related. Okay. Next important question. The minimum energy required to remove an electron is called, of course, the minimum energy which is required to remove the electron from the metallic surface is known as a work function. That is the definition. Okay, that is the definition for work function phi. Okay. In fact, we call it as phi naught. That work function is phi naught. Next question. The photon has no electric charge, kinetic energy, momentum, mass. So clearly photon is a neutral thing. So it is having no electric charge. Okay. Photon has kinetic energy, photon has momentum, photon has mass, but it does not have electric energy. Okay, I mean to say it is neutral. It does not have electric charge. Okay. So this is also one of the important question. So with this, I stop here. So let me continue with the remaining part of the chapter in the next class. But I will upload the next class only when I get minimum 100 likes for this class. Okay. Only after I get 100 likes, I am going to upload the next class. Okay then. Please keep working hard, because you all know that the recruitment can come very soon. So please don't waste time, because every minute counts from now on. Okay. Keep working hard. Don't waste time and be positive. Okay. Thank you. All the best. Bye.